Welcome to Topic 3, Unit 2, the Sum and Difference Formulas. In the investigation, you had the opportunity to see how the sum and difference formulas have been developed. Now we're going to have the chance to see how we can use them. At the end of this video, make sure that you transfer the sum and difference formulas for cosines, sines, and tangents onto your identity sheet. Example 1, find the exact value of the cosine of 75. Well, if we're going to use a sum and difference formula, we have to figure out what two angles on our unit circle add up to 75. Well, that is going to be the same as the cosine of 45 plus 30 degrees. So I'll put this into the formula, and this becomes cosine 45 cosine 30 minus sine 45 sine 30. Now I'll substitute those values in from my unit circle. Cosine of 45 is root 2 over 2. The cosine of 30 is the square root of 3 over 2. The sine of 45 is root 2 over 2, and sine of 30 is 1/2. And then I'll just simplify. Square root of 2 times the square root of 3 is the square root of 6 minus the square root of 2 over my common denominator of 4. Example 2, find the exact value of the cosine of pi over 12. Now this is a little bit trickier with radians, but it helps if you start by just making a list. We know that pi over 6, if I multiply by 2 over 2, is 2 pi over 12. Pi over 4, if I multiply by 3 over 3, is 3 pi over 12. And pi over 3, if I multiply by 4 over 4, is 4 pi over 12. So you can see that I could say that the cosine of pi over 12 is exactly the same as the cosine of 3 pi over 12 minus 2 pi over 12, which is the same as the cosine of pi over 4 minus pi over 6. Now if I put this into my formula, this is the same as cosine of pi over 4 times cosine of pi over 6 plus sine of pi over 4 sine of pi over 6. I'll get these values from my unit circle. The cosine of pi over 4 is root 2 over 2. The cosine of pi over 6 is the square root of 3 over 2. Sine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2, and this simplifies into the square root of 6 plus the square root of 2 over 4. Example 3, find the exact value of sine of 7 pi over 12. So we'll be using the sum and difference formulas for sines, which is shown above, and I'm going to rewrite sine of 7 pi over 12 as sine of 3 pi over 12 plus 4 pi over 12, which is the same as the sine of pi over 4 plus pi over 3. I'll expand the formula, and this is going to be equal to the sine of pi over 4 cosine pi over 3 plus the cosine of pi over 4 and the sine of pi over 3. I'll substitute in the values. Sine of pi over 4 is root 2 over 2. The cosine of pi over 3 is 1/2. The cosine of pi over 4 is root 2 over 2, and the sine of pi over 3 is the square root of 3 over 2, and this simplifies into the square root of 2 plus the square root of 6 over 4. Example 4 shows a different way that these kinds of problems can be solved. So they give us that if sine of alpha equals 4/5 and alpha is in quadrant 2, and the sine of beta is negative 2 over the square root of 5, and beta is in quadrant 3, find the exact value of cosine of alpha. So I can make a triangle to solve this problem. And so I'm going to draw a triangle that's in quadrant 2. Call this alpha, and the sine of alpha is for over 5. Now, by Pythagorean theorem, I'm going to get, or just noticing this is a Pythagorean triple, I'm going to get that the x-coordinate is 3, but in quadrant 2, x is negative. So from my picture, I can say that the cosine of alpha is equal to negative 3/5. Part B, the cosine of beta. I'm going to use the same process, but now I'm going to draw my angle in quadrant 3. So here's beta. The sine of beta is opposite negative 2 over hypotenuse, which is the square root of 5. And to find my missing side, I can say that x squared plus negative 2 squared is equal to the square root of 5 squared, or x squared is equal to 5 minus 4, which is equal to 1, which means x is equal to 1. But x is negative in quadrant 3, so I'll label that side as negative 1. And now I can say that the cosine of beta is negative 1 over the square root of 5. And if I rationalize, I get negative root 5 over 5. Part C, we're going to find the cosine of alpha plus beta. So I'm just going to expand the formula. The formula says that this is going to be cosine alpha, cosine beta, minus sine alpha, sine beta. And I have all of these values accessible to me. So the cosine of alpha I calculated as negative 3/5. The cosine of beta is negative square root of 5 over 5 minus the sine of alpha was given, that was 4/5, and the sine of beta was given as negative 2 over the square root of 5. So now I get 3 times the square root of 5 over 25 plus 8 over 5 times the square root of 5. So if I rationalize, I get 3 root 5 plus 8 root 5 over 25, or 11 root 5 over 25. Part D, sine alpha plus beta. So I'm going to expand the formula. So this is equal to sine alpha cosine beta plus cosine alpha sine beta. I'll substitute in the values. The sine of alpha is 4/5. The cosine of beta is negative 1 over the square root of 5 plus the cosine of alpha, which is negative 3/5, and the sine of beta is negative 2 over the square root of 5, and this gives me negative 4 over 5 root 5 plus 6 over 5 root 5, which is equal to 2 over 5 root 5, and if I rationalize, I get 2 root 5 over 25. Example 5, verify that cosine alpha minus beta over sine alpha sine beta equals cotangent alpha cotangent beta plus 1. Well, it might not be clear which side is the simpler side, but to me the side that has cosine alpha minus beta in it seems more complex, so I'm going to work on the left side. So I'm going to expand using my formula. So cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta, and this is all over sine alpha sine beta. Is that equal to cotangent alpha cotangent beta plus 1. Now sometimes it's a good idea to take multiple terms over a single denominator and rewrite them as separate fractions. So I'm going to say the left side is cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over sine alpha sine beta. Is that equal to cotangent alpha cotangent beta plus 1? Now if I look at the term on the right, that actually completely cancels out and that turns into a 1. When I look at cosine theta over sine theta, that's the same as the cotangent of alpha, and the cosine of beta over sine of beta is the cotangent of beta, which is what I was trying to equal. So we are verified. We also have sum and difference formulas for tangents, and we'll do a practice problem with this. Now remember again that pi over 6 is 2 pi over 12, pi over 4 is 3 pi over 12, and pi over 3 is 4 pi over 12. So when I think about the tangent of 19 pi over 12, I can say that that's equal to the tangent of, well, 19 pi over 12 minus 3 pi over 12 is 16 pi over 12. So I can say that this is the same as 3 pi over 12 plus 16 pi over 12. That adds up to 19 pi over 12. And this is also the same as the tangent of pi over 4 plus 16 pi over 12 simplifies to 4 pi over 3. So we'll expand the formula. This is equal to the tangent of pi over 4 plus the tangent of 4 pi over 3 over 1 minus the tangent of pi over 4 times the tangent of 4 pi over 3. The tangent of pi over 4 is 1. Now 4 pi over 3 is in quadrant 2 where tangent is also positive. So this would be equal to the square root of 3 over 1 minus 1 times the square root of 3. So I need to rationalize that denominator by multiplying it by its conjugate, which is 1 plus the square root of 3 over 1 plus the square root of 3. If I distribute the numerator, I get 1 plus 2 root 3 plus 3, and the denominator, because they're conjugates, becomes 1 minus 3. The numerator becomes 4 plus 2 times the square root of 3, and the denominator is negative 2. If I divide both terms by negative 2, I get negative 2 minus the square root of 3. That's all for now. Thanks for watching.